Let's talk about how we can create or make any kind of our type or any kind of our function that's make more generic kind of things. Generic means or let's say we are writing one function, and that generally take input maybe integer. So always whenever going to the call from main function, always you have to ask the integer function. Okay, so this is the function defined that's work for very well of the given specific one kind, the one types of value. Is it same business logic, same code I want? It's also work for the different data type. Maybe I want for float, maybe for the double, maybe for the different kind of data types. So generally what we have to write different function. So let's say like one function, maybe function maybe test. Okay, this will take one uh, take variable a, right? And this maybe returns a. So here might we say return a multiply a. So this is the function. Let's okay, test square u r. So this function is only you can say is work for input integer. So it's good, it's fine. Let's I say, hey, let's test is for like number input 5. So if you pass the number 5, they return 5 multiplied by 5 again. Okay, so it works and fine, there is no problem. But sometimes similar function I want to square for the float value or square for the different value. So surely our this function maybe not works. Okay, or maybe some different data types. So what we can do, if let's say want to for the float, so we can again go write a function like, hey, I am going to write a function, a particular function test maybe one, and it for like a float. Okay, float, and they return the float. So this is very handy. It's now works. When again I can go and test for the float. Okay, and if you run, it will work. So what do you think? Our business logics are kind of same, but we have to go and write different functions. So in this place, our code, this code, my business logic, is not more reusable for different data types. We are going to write different code. Okay, maybe you want to just return uh, some multiple value. So even those scenario, we have to write different code. So is it possible maybe for int, float, long, double, different data type? So here our Go language support the concept of generic. Okay, generic. That means we are going to write a function that's not take input as a specific type. They can take maybe sometime integer, sometime float, sometime double, anything. Is it possible? Yes. So we can write such code or even kind of anything. So this is one level where generic make help, and also whenever we are going to define some kind of maybe our placeholder variable, generic variable can be your a primitive value or your custom types. Custom type also can be generic. Instead of I am going to holding the integer variable, maybe like this way. Let us we have a one type maybe container. Container. We have a type container. Let's say we have a value. So here our container is the object, and this type can hold the value of only integer. So this container can possible to use the, if I'm going to use, hey, let's say I'm going to create a container, and here just like just print C. So in this way our container only can hold the value integer, but this container is not sufficient, can hold the value of maybe float, maybe double, maybe anything. So generally for the code reusability or type reusability, Go language support, hey, in those scenario, even if you don't write, here might be a character contain int container, maybe good option. So here suddenly say, hey, that is int container. Okay, that's hold only integer value. If you want to maybe float container, right, you can say, hey, this is my float container, and here say this is my float container. Okay, so in this way, generally later part can say, hey, I am going to, this is my int container. Similarly, I can write my float container. Float container and help value. This way. So here, what's I'm trying to convey, till now, whatever we study, generally for creating any types or creating any function, that generally always we define the fix some kind of data type, maybe int, float, string, or double, anything, right? So here generic help us, we can define only one function, one container that can hold different type. Let's think as a container, how can define the generic container. So instead of this, I'm going to say, hey, whatever this container, I'm not going to write this way. Instead of that, I'm say, hey, this simple container, not for a specific, this is a container, and this should be kind of any types. So let's T. Here, what do you mean a T? How can define T? What is the T? Somehow you have to mention T is the kind of a what? Maybe you can say, hey, T is maybe any types. So here, GoLang have a one option. You can say, I'm going to create one container or one variable that can hold any. Okay, that can hold any kind of. So here, the same things. Instead of this, hey, I am going to just use container. Okay, just use the container, and similarly just use the container. Okay, so in this way we have to tell compiler. Okay, so what kind of T would be? So quick fix. Okay, so here you are trying to say, hey, I am going to pass this the int value. At the same container we are going to pass for the float value. So this kind of, you can say, now we are able to create container that can any types. Maybe you want a specific value like a float or double, you can also change. What say incomplete? Fix. This is the way. Yes. So here simply say container C2 struct. Depend upon its value, this container can works. So objective here, the Go language say, even you can specify this for a specific one integer or a specific fold or maybe 2 or maybe 3. Okay. Even the, let's suppose compile and run it. What is say? Cannot generate type tree without any compiler. Okay. So my objective is that we can define any kind of a custom object or type or struct interface that's work for a generic. So even now, all this kind of int container, float container not required. It's still the very sufficient, and here you can do any kind of you can say implementation. Okay, even you can for use for container use for float. Even you can use for the string. Even you can for the boolean. So notice we have created just only one kind of container that is sufficient to types hold any kind of, maybe you can say integer, maybe float, maybe string, or maybe bool. Okay. So this kind of maybe while writing any kind of a function or interface or a struct where we are going to type a specific type, maybe you can think we can write as a more generic way. Okay, so let's go to example. Even we let's write a one function. Okay, I am going to write a one function. Okay, and function that's maybe some function. Some function can okay take two integer variable and return an integer. So if this function is work fine for integer, but might be it's not fine for, it's not work for the float. Okay, so if you call here a sum and right s equal to, so in this way it's work fine, but can I use the same sum function for the floating point number, like maybe dot 5, okay, dot 3? Is it we can do? Surely these sum functions is not more capable to handle this kind of thing. So instead of writing some like specific int, this is some only managed for your int types, right? You can say manage int here, say whenever same kind of variable, you can simply say a comma b and return int return, it's work. So here if this I call, it's only work, but this is not work. Might we have to similar kind of code we have to write, hey, some function that for the float, and here you can say float. Okay, so in this way this you can, but notice the same kind of code we are going to copy paste only to the different data types. So here instead of writing different function, why we cannot use just like a generic, so that our function is more kind of a generic. So how to do, let's I am going to write a one function, just not for just for generic sum, okay, and this will return. So question is, what kind of input I need? Surely I need a and b value. I need a comma b of maybe some t type, maybe some here notice even here we are whatever right container t or here there is no any guidelines, you can say t p whatever you can say. So here might be say, hey, I am going to say a and b can be number, and we number and return number, okay, and here question C. Let question C, what is the number? Generally, if int and b, here we can define my own type. That's make what is the meaning of number. Here say, hey, I'm going to define my type number interface, and here I can say this is maybe int. You can say this is allow int, and maybe it's work for float. So in this way you can define this number is for integer and float, okay, or even you can write this kind of okay. What is this saying? Okay, okay. So no, this somehow we have to tell this is the type generic. So here say maybe this is kind of a integer, maybe define number, okay. Oh no, I'm not interested. So I'm going to say this is that one way, that's one way type t here. So whenever generic way, whenever we are going to say, hey, this should be generic, the generic you can write here, this is to say, hey, this is the my number, generic number, okay, generic number, and What is the type? Type can be your int, sorry, int, or can be float, float. Okay, so in this way you can say return your and take n. Okay, so in this way, just some different way. So this is the way you can say I'm going to write the sum function that can take integer or float. So now and here you can input a and b and type of n and return a plus b. Right. So here you can say so notice our this sum function now work for your to integer and even work for you to float or even you can other parameter you can type. So this is the one way you are defining this types your whatever the information and here mention hey this can be number float everything, right? It works. But these things can be defined in the separate. Maybe you want to later part, hey I want to kind of maybe for double. Okay, so these things you can pass any number of parameter. Okay, why not? Checking here. Okay. Okay. So here you can define number, float, type, any types. So generally, maybe if I write another one function for minus, so what we have to do, we again go, that's minus, minus. So again, the same structure, I have to copy this. And if this is a more, why then not reuse this? Maybe you can define my separate types and use them, right? So instead of writing a different function to duplicate this kind of types, I'm not going to do something like, hey, here we are going to write my separate type. So here this should be going to separate types, create type, type maybe additive, if the I have just say type t instead of the simple say number. In this way number, this is the yes number kind of float kind of anything. Here directly you can say just remove this kind of a code, just say hey I am going to form product, here say a comma b, yeah say number, number, okay, return number, okay, return. Okay. So this is the way you can also define the Somehow, why this type interface this here in this way? I think what they say. How to fix it? No, can't create generic number type. Again, they are not taking. Hmm. Why that? Somehow there might be. I want to go. Hmm. So objective is that here we can type stuff somehow. And what say they? Maybe you can write this type information. And here you can use the look like types. So here we can define generic types for maybe here somehow I'm missing the syntax. Here's ask define define the generic number types define generic custom number type. So you can ask them. And here there's something syntax here somehow maybe two options, maybe use the tilde, and here you can define any number of operator you can say. Okay. So this is the way you can define this and this maybe this way or this way, multiple way you can say. Yeah, this is the way I am same thing. I say hey interface. Okay. You can define. So it should works. Let's call the product product. So this is the way you can define your number types, and many places you can just use the number. Here you can define any number of mode type whatever you want, maybe float, double, 16, whatever you want, right? Already you have it float. Here you can say int float, whatever generally number types, whatever the number you have. Let's run it. What they are saying. So simply say just interface and whatever the types you have just mentioned, and it your number. Now many places you can just use the number. Okay, what's a number? Types number, not on, cannot types number outside of the interface contain the type. Okay, so let's check. So here they mention any types you mention, or simply say, hey, these are the things already. Just run it. Or write generic some function that, okay, yeah, it's working. So simple, this is the types. Yeah. Something we are doing wrong. Syntax is very right. So so bad. What is this? This line say simply say define this types number, type number, and just run it. And this is the function. Okay, and we have to, we are just mentioning missing side here, say this, I got it. Whenever you are defining your own custom type, okay, this is my type number. So whatever the function you are going to write, before writing the function, we have to tell generic, hey, this is the our number type, maybe n. Okay, and here say this is the return, take input n and return output n. Okay, so in this way you can tell the function, hey, this is my product function, take a 2 input a and b and return types of number, and you can pass here, like they mention here number n and type returns, and you can just run it. N is what say, so what saying n? This is already given somehow same things. So as of now, let's copy this. I'm copying this. As of now, let's comment out this code. Okay, comment out this code, and this comment out this code. Okay, and I can simply say just define my type. Yes, just define my type. This is my type. Just define the sum function. Let's test it from the main. Okay, okay, okay. So this sum function define the number types a comma b and return n. So generally, whenever you're going to define types, you can just mention what this type can be, and any type you can run. Let's say something I miss. Yeah, I miss this kind of this. Just comment out and just run it. So very you can say very convenient way, whenever you're going to define any function and you want to not specify a specific type, you can define n, and here what would be the okay number types. So it's works. Okay, it's worked. So that means I got. So just let's uncover it's works. Okay, so whenever you are going to define your number, you just say, hey, this is my product. That will take two input. That would be number types. You can say that would be number types and return number. Okay, you can write this way generally, but this is the custom type. You can define here what is this and give some shortcut, maybe name, say name, and here in replace this is the number. Okay, this is the number. Okay. In this way you can use now instead of here simply say instead of number here, so simply say not defining the manually here, just already define this is the custom type number. You can say, hey, this is the number. It's work. Similarly, this is also works for this way. Okay, so now this is sum minus product, everything work for your custom time. So this code you cannot going to the copy every place. Okay, so instead of copying this defining every places, okay, so instead of, hey, this is I'm defining this is number and float, this type here defining, instead of this I can define one common place like here. Okay, and say this is the number, and instead of writing this every places I can say, hey, this is the number, and they return take input types. Okay, so this is the way you can define your function that can take generic. Maybe here you can later part you can increment for more number, right? Okay, increment multiple kind of things, right? So all the things we can just replace here. Later part you can define whatever that you have. Okay, so even notice this is the very bigger kind of data types. They can support different type things. Okay, this is the duplicate. Okay, and this is also duplicate. So now your number is your custom types, and you can use any places where you want. You want to plus, minus, multiplication, division. So I want to multiplication. Okay, function multiplication. Okay, so in this way you can say multiplication or division. Okay, function division. Okay, so this way now this function is divide everything, integer, float, double, every candidate. So here you're not mentioning any specific data type, you can just mention the generic. So in the case of Go language, defining generic is so you can say simple. Just define your own types, and whatever types you can just mention this type you can use in the function place whatever you want. So here I'm not going to say this A and B are the int type or float type or double type, whatever, right? You can say, hey, this is my custom type, number types, maybe additive types, that can. Okay, even you can write a function that can define the kind of a mixed parameter. Maybe let's say, hey, we have a one function that maybe take maybe say message, say hello message function, say message, print message, you can say print message. Okay, and you can say our message can be any types. Here you can pass, hey, my message would be in. So here, if you go here, and you can say, hey, print message. Maybe you can print hello, maybe number, maybe double, maybe boolean, maybe anything, right? So whatever, this function is so generic, and this can be take any kind of type, because now we define the this print only take a string, or only take a boolean, or only take a function. You can say, hey, this is my generic type, and this can take any types. So whenever you are going to write a function, and that function you think that can be reused for different data types, so instead of writing a specific function like in this way, hey, print message, print message, print message like for instead string. So this is only print your string message, right? Instead of generic, generally you are writing function this way. The print one message only can print a string. So this, if you go here, hey, this one can print one, but this function print one cannot print like your any message 45, because this function is not more kind of generic. So these are the not generic functions, because you are written your function that only take string types of message. So this is your normal function. Generally, whenever thinking initially write a function that's work for a specific type. But sometimes you can say, hey, this my code, this my business logic is very generic, and that can work for the different data types, different kind of value. So instead of mentioning, you can say here a specific type. So I'm not going to mention here any specific types. I can say no, this should be any kind of T, types of generic T. So what is the T? T can be any types. Any types can be string, float, double, anything, whatever you want. So whenever you are writing a generic function or generic container, a generic type, you have to use this. So here, this is the place. If you this is the placeholder where you can say what is this T. T means what? T means only integer and float, or T means specific. Here you can T can be like a number. So only our function can maybe you can write function that hey, only print the number. So here I can say T could be my number, okay, and this is a 2. Okay. So this function print function 2 take a message that types of a T. T can be any means or any specific or custom type. So here number is my custom types, and custom type you can say define, hey, this is my custom types, and these types can be only the all the number systems. So here print 2 function, if you going to print like this, and here say this is the 2, this is the 2, this is the 2. Okay, notice this will work fine for the integer, this will work fine for the double float, but this is not fine for the boolean, because our number is not a boolean, because here our number definition say, hey, only support these kind of things. So this is the you cannot possible. So here intention is that whenever you are writing the any function and you think this function, but whatever the business logic here you written, that can depend on a specific input type. Okay, this code is very specific for the integer only. That time you can write your function should be as a specific function, not generic. But you think whatever I'm writing this code can be applied for A types as well as B type as well as C types. So those functions we have to make kind of generic. So how to make a generic? Just change your specific data type to the any specific any keywords, and here mention what this type, where you can give to the hint of the type. What is the T? Go compiler? No. So before your start bracket, and here is the place, open and close curly braces, and make, hey, T is the kind of type. Even here you cannot say only T, any word you can choose. This is not a specific. Maybe here I can say maybe R. Okay, this is not any kind of violation or any kind of restrictions. Always you can T, right? So here word like a T or R or number or any, just hint to Go compiler, hey, this is kind of a generic. Okay, and similarly you can use, okay, it works, right? So you can say here in short, whenever you are writing any function, you can give the specific types, maybe int, maybe full. Generally we are writing our function for the specific input types, it's okay. But our business logic is not highly dependent on the specific input type. Then you make your function generic. Generic means your input types is not only string, can be integer, can be float, can be long, can be double, can be pointer, anything. Then we can say remove the specific type and replace with any types notation. This type notation, you say here you can write any one word, R, T, Q, type, anything. But what is this? You can tell this the placeholder. This still can be placeholder. This is a place. Here you can give the definition and meaning. Hey, this is the meaning. R means that can be any types. R, T means can be only number. R can be only string. Okay. R only string and float, only two. So even you can say this is the only function for the two, not for many. You can say, hey, this T and R and S. Here say R can be only string, R can be float. So in this way, you can also specify R can be any, or R can be a string or float. So this is the placeholder where you can define your generic. So this function work for this, work for this. Okay, this works. They can only support, and if you try to, like, let's try to RS for like only number, so it's not happy, because this function say, hey, this function is a very generic types, but they can support only two kind of generic, string and float. So you can pass here a string, it's okay. You can pass floats, okay, but you cannot pass integer. So this can not possible. So now here my intention is that please be think where as possible you can write your function generic, you can use. Why? Because the business logic, the code you are written, that are not depend on the specific types of the logic. Then your function is the candidate for writing the generic. So that your code can be reused. Okay. So type informations we can inform to the Go compiler, hey, whatever the type information I'm using, type what type, where the meaning of types is the inside your placeholder. This is the placeholder where you can tell them. Okay. So these are lots of things about the generic, but as of now, let's start implementing generic. Maybe you can use any types, and maybe container, or a maybe variable, or even you can write in the function should be more generic. Okay, so whenever you are going to type calling your function or function or any kind of struct or any kind of interface, they are not highly dependent on a specific type. You can say, hey, this can be generic. Right? So hope this kind of in code, this kind of a generic, whenever you're writing the your generic code is a kind of a placeholder. You can say, hey, just I'm defining this is my placeholder. Here I'm not saying to, hey, this is the my uh, placeholder for types int. I'm not going to say, hey, this is only hold the integer value. Okay, this is means integer value. Bro, I'm not more interested. I can say, hey, this can be type t. A type t can be give the meaning. T, I can define t. T can be number and float, or t can be number, float, and string. So this placeholder now capable for storing three kind of value or any kind of value. So generic give us more flexibility where your variable, where your function, where your struct not defined for specific kind of data types. You can define your function, then can take variety of input, maybe integer, maybe float, maybe double, maybe long, maybe string, maybe function. Okay, so let's use this kind of a generic. And if you might be think in many library, these generics are used. Notice here we are using the function like print. Here you can pass the number, here you can pass the float, here you can pass anything, right? So notice this is the function. That print function is written as a generic. Notice this is the written as generic. Hey, this will take a this will take a print dot means dynamic value, but types, notice types any means they can print maybe integer, they can print maybe float, they may print anything. Okay, so the many Go library are using this generic so that they can avoid duplicate code. So generic help us same kind of nature of function. We are not going to write again and again, one for integer, one for float, one for a string, right? The same business logic. Why I am just duplicating our code for the different kind of input. So yes, hey, no, I'm not going to write 3 copy of the same code. I'm just writing only 1 copy and say, hey, this is generic. You can place your code maybe X types or Y types or T types. I will manage. So generic help us to avoid writing same code, copy paste or duplicate code. And generics are heavily used by the library creator. Even you also try. Okay, so generic is very powerful tool to writing your concise code and code reusability and enforce your specific types, custom types, what you want, whatever the inbuilt types, just like the GoLang support. Apart from that, you can combine and make your own custom types. Like here, we make our own custom types number. There is no specific number types in the Go library, but you can customize, you can define. Okay, so hope this information is very helpful, and already Go documentation is given full detail how we can use generic, and Go language support encourage you can write your function, your type, your struct, your method as possible generic, so that you cannot duplicate your code for the different kind of input. Okay, so let's try to write some code, and we'll if any doubt, surely we can correct. But this is very simple things, just kind of a different syntax, a different way to write your function as generic. Thank you for watching this